तो टाइम बाउंड चलना जरूरी है, हर चीज एज पर रूल।
बिल्कुल।
है
दे गो इन नैनो सेकंड्स में जाते हैं आजकल।
यस यस। पांडे जी नमस्कार। पांडे साहब, मुकेश पांडे जी नमस्कार।
सर नमस्कार।
पांडे जी लाइन में हो।
मुकेश पांडे जी नमस्कार।
सर नमस्कार नमस्कार
नमस्कार नमस्कार।
अभी
पांडे जी के दर्शन हो गए महीनों पर, सालों बाद।
सर आप तो बुलाइए, डायरेक्टर साहब जब बोलेंगे मैं हाजिर हो जाऊंगा।
बिल्कुल।
हमारी मुलाकात भी डायरेक्टर साहब से बहुत कम होती है, बहुत बिजी है डायरेक्टर साहब।
जी
झांसी की रानी की जगह से बोल रहे हैं पांडे जी।
अब आप लोगों ने बिजी कर रखा है डायरेक्टर साहब को।
तो मैं तो रिटायर्ड हो चुका हूँ सर।
अच्छा
हाँ, मेरे को 3 साल होगा।
अच्छा, चलिए फिर आपको आमंत्रित करते हैं। बिल्कुल
बिल्कुल आएंगे सर,
जी
तो जुड़े हुए हैं हम।
जी।
Shall I start, sir?
हाँ,
Ritika, just a moment.
Okay, sir.
कैमरा बंद कर लीजिए। कोने में जो फर्स्ट सेकंड ये सब दो है ना, एक माइक्रोफोन का, एक वीडियो का।
पांडे जी नमस्कार, कैसे हैं?
नमस्कार नमस्कार, ठीक है सर, आप कैसे हैं?
बस बढ़िया, फर्स्ट क्लास, मजे में।
सर
हाँ, चालू करें क्या? डायरेक्टर सर चालू करें। रिकॉर्डिंग।
Good evening, all of you. I, Ritika Nair, on behalf of ENTC Department, SGSITS Indore, welcome you all in 2-week AICTE Atal Faculty Development Program on Design and Development of Academic Institute Nano Satellite with Indian Space Perspective, DDA-INS 2023, organized by Center for Remote Sensing and Satellite Technology, CRSST, Electronics and Telecommunication Department. Our college, SGSITS, has a vision of becoming a frontline institute in science and technology, making significant contributions to human resource development, envisaging the dynamic needs of society. Our mission is to generate experts in science and technology akin to society for its accelerated socio-economic growth in a professional and challenging environment, imparting human values. Keeping up with our mission, here we are with a 2-week AICTE Atal FDP course for faculties and researchers to give them sound domain knowledge, application based knowledge, so that they can easily connect with industry. So, here I welcome Director SGSITS Professor Rakesh Saxena Sir, our chief guest for today, Professor Mukesh Pandey Sir, Vice Chancellor, Bundelkhand University, Jhansi, UP. Our expert for today's session, Dr. P.K. Jain Sir, Director, Program Management and Authorization, Indian National Space Promotion and Authorization Center in Space, Ahmedabad. Professor S.K. Soni Sir, Founder and Coordinator of CRSST. Head of Electronics and Telecommunication Department, Professor Anjana Jain Madam. Coordinators of the FDP, Professor S.K. Jain Sir, Professor Shailendra Sharma Sir, all the faculty members and participants in 2-week AICT Atal FDP DDA-INS 2023. It is my pleasure to request Professor S.K. Jain Sir, who is CRSST coordinator, to please welcome all the participants.
Thank you very much, Ritika. I would like to thank our director sir, Professor Rakesh Saxena, whose constant inspiration just helped me and motivated me to get involved in this huge FDP 2-week. I also welcome to Professor Mukesh Pandey sir, Vice Chancellor of Jhansi University, co-founder of our CRSST, Professor S.K. Soni sir, our guest speaker, Dr. P.K. Jain Sahab, and our head of the department, Professor Anjana Jain Madam. Our advisors are also available, Professor Vyavare sir, and all the participants. I welcome you all. This FDP is of 2 week actually. Just I will take 1 minute to brief it. It is a 2-week FDP. It seems it is exhaustive, but it is not exhaustive because 1 week is online, 7 p.m. to 9:30 p.m. and from 13 to 18 Feb. And we'll start offline FDP of 1 week from 20th to 24th February. And we have, it's our privilege, we'll have a scope to hear very renowned speakers from ISRO's, from RRCAT, and our institute also. So, and we have just included some industrial visit also in this. So I hope this is going to be very, very useful for all the participants. Especially we have focused participation in Indore region only, because Indore being in MP seems little bit isolated as far as the space activity is concerned. So as per the ICT Atal norms, we were focused in 100 kilometer only. So we got plenty of participations, but we have selected only 50 because of the constraints. So I hope this is going to be very, very useful for all the our audience. Thank you very much.
Thank you, sir. Now I request Professor S.K. Soni sir to brief us about CRSST. He is also the founder and coordinator of CRSST. Please, sir.
Thank you very much. You're listening to me? My voice is coming to you?
Yes, sir.
Thank you very much. I don't know. It's a very long history of CRSST we have during the tenure of Dr. Rakesh Saxena. In 2018, we have created one center for remote sensing and satellite technology. As far as remote sensing is concerned, we are working for almost 4 decades in the institute. And with the Dr. Saxena becoming a director of our institute, he suggested to me that we should have a satellite technology also. And about 3 years back or 4 years back, we started a center for remote sensing and satellite technology. Yes, it was my privilege to be a founder coordinator for CRSST, and when I retired about 3 years back, I have handed over this charge to Professor S.K. Jain. We are working in this area. We have conducted a number of programs in the past also, along with the antenna societies also. And this particular program of under Atal scheme of faculty development program, we are working on a nano satellite. This is a very emerging area, and in our state of Madhya Pradesh, so far, we are the lead institute who think about nano satellite. And I'm sure that this 2 weeks program under the able coordinatorship of Professor Shailen Sharma and Professor S.K. Jain, it will be very beneficial to all the participants. And of course, with the encouragement that we received from our Dr. Rakesh Saxena sir, this program will be a, what you may call it, to be a very important mission in the development of satellite technology. I would like to add that yes, at Dr. S.K. Jain added, we have a couple of centers in Bhopal also. They have got a very good one of the center of they receive the signals, and I'm very happy to meet or see Professor Mukesh Pandey. I was not aware of it that he has joined as a vice chancellor in Chhattisgarh or Jhansi. I knew when he was in RGPV Bhopal. I'm very happy that under his leadership, some other institutes, he represents a UP also. We will join hands with him, and let us hope that we come with a very fruitful, not only knowledge, but not dissipation of knowledge, but experts coming from various IITs and ISROs and even RRCAT. It will be a good venture. Thanks very much for giving me an opportunity to be the on the inaugural day I'm attending this program. I wish good luck to all the organizers as well as to the participants. Thanks a lot.
Thank you, sir. Indeed, your work is really appreciable and beneficial for the college. We hope to continue your legacy. Now I request Head of the Department, ENTC Department, Professor Anjana Jain, Madam, to please say a few words.
Yeah. Thank you, Ritika. Thank you, Ritika. Honorable Director, sir. Honorable Pandey, sir. Jain, sir. Our coordinators, Senior Professor Soni, sir. Vyavare, sir. I am very happy that the department is organizing this Atal FDP course. Actually, Atal has its own strict rules for participation, for expert lectures. So the coordinators has put lot of efforts to arrange for the good experts from around the India and mostly from the research centers like RRK, ISRO, and all the participants will get benefited by this particular Atal FDP. And I hope in our department also we have a research laboratory. The coordinator is sitting there only, you can see here. So in future also all the participants will get benefited by this laboratory and with the CRSST. This is a very new venture and very innovative in our state that we have CRSST center, and we are very thankful to our mentors and the directors, sir. They are all putting lot of efforts to make it like viable, to make it liable, and we will arrange some other programs also under the CRSST, and the participants will get definitely benefited by this. So thank you for giving me the opportunity. I hope all the participants will attend this activity with full energy and will get benefited by it. Thank you. Thanks a lot.
Thank you, ma'am. Now I call upon the navigator of this flagship of knowledge, Professor Rakesh Saxena, sir, Director SGS ITS, to please say a few words.
Thank you, Ritika, for very good comparing. Our chief guest, today's chief guest, Vice Chancellor Jhansi, Professor Mukesh Pandey ji, mentor of CRSST Soni ji, our coordinators SK Jain and Sailen Sharma ji, our Professor PD Vyavare sir, and Professor PK Jain are today's speaker, and all participants. First of all, congratulations to CRSST team, institute team, and all associated with this for this initiation. 3 साल पहले मैं भोपाल में कहीं बैठा हुआ था, तो सीएम हमारे चीफ मिनिस्टर के सेक्रेटरी थे, उन्होंने हमको बोला कि हमारे सीएम जब विदेश में कहीं पर देश में कहीं भी घूमते हैं तो हर स्टेट का सीएम बोलता है कि मैंने ये बड़ा काम किया, मैंने ये बड़ा काम किया, मैंने बड़ा काम किया, लेकिन मेरे स्टेट के इंजीनियरिंग कॉलेज क्या कर रहे हैं, क्या कर सकते हैं, वो बोलते हैं मैंने नैनो सैटेलाइट किया. तो इमीडिएटली आफ्टर लिसनिंग दिस आई केम बैक एंड आई डिस्कस विद सोनी जी, और मैंने सोनी जी कहा कि हमको प्रोसीड करना चाहिए. देन वी विजिटेड ISRO also for 3 days for this all these things. Then we visited 2 of the institutes जिन्होंने ऑलरेडी सैटेलाइट बना करके और इसरो ने लॉन्च किया है. उसके बाद हमने ये CRSST बनाया, सेंटर फॉर रिमोट सेंसिंग एंड सैटेलाइट टेक्नोलॉजी. इसका पर्पज यही था कि रिमोट सेंसिंग में तो काम करना है हमको, क्योंकि स्मार्ट सिटी और बाकी जगह इसकी जरूरत है, बट एट द सेम टाइम वी हैव टू वर्क विथ नैनो सैटेलाइट आल्सो. So this was the theme of CRSST, and this FDP, Atal FDP is given by AICT. So again, it is very good chance for us, and we have already given application to ISRO also. Or soon there will be a good news for us that yes, we can give a satellite for launching. Let us hope from God. I discussed with Nagar Nigam Lalwani ji, I discussed with the state government also. They are all ready that if you are sanctioned the nano satellite, then we'll fund you also for this purpose. फंड भी हमको मिलने के लिए कमिटमेंट हो चुका है. तो विद दिस एफडीपी, ये वाला जो डिजाइन एंड डेवलपमेंट ऑफ एकेडमिक इंस्टीट्यूट नैनो सैटेलाइट जो है, इसके जो स्पीकर्स हैं, दे आर ऑल फ्रॉम इंस्टीट्यूट जिन्होंने नैनो सैटेलाइट बनाया है. आई रिक्वेस्ट ऑल पार्टिसिपेंट्स, जितने भी है, अभी मेरे को 28 दिख रहे हैं, खाली 30 पार्टिसिपेंट्स हैं, जबकि टोटल 50 है. तो जैन साहब, आप सबका रिकॉर्ड भी रखिएगा, जरूरी है रिकॉर्ड रखना. बट एक बहुत अच्छी चीज हुई है कि इसमें स्कूल पार्टिसिपेंट, स्कूल टीचर्स भी हैं, और करीब 9 या 10 स्कूल टीचर्स ने भी ज्वाइन किया है, जो कि इंदौर शहर में साइंस में बहुत अच्छे शिक्षक हैं। वो अपने अपने स्कूल में बच्चों के साथ इन्वॉल्व है। तो ये एक बहुत अच्छी चीज हुई है कि हमारी जो टीम बनेगी नैनो सैटेलाइट की, उसमें स्कूल के शिक्षक भी रहेंगे और उनके साथ साथ स्कूल के बच्चे भी पार्टिसिपेट करेंगे। तो उनको भी एक नया विजन मिलेगा कि सैटेलाइट क्या होता है, कैसे काम करता है, और वो दिन रात आकर के हमारे CRSST में काम कर सकते हैं। तो एक अच्छी अपॉर्चुनिटी है। मैं सभी पार्टिसिपेंट से चाहूंगा कि वो आपस में ये बोले कि इसको, चूंकि ऑनलाइन है, जरूर अटेंड करें और ऑफलाइन वाला सीरियसली अटेंड करें, जिससे कि सैटेलाइट बनाने में हम बहुत कुछ कर सकते हैं। दूसरा, एक हम लोगों ने सोचा है कि हम लोग एक सूटकेस सैटेलाइट बनाएंगे। सूटकेस सैटेलाइट मतलब हमारे कैंपस के लिए होता है, उसको हम सैटेलाइट मान लेते हैं और उसको अलग अलग जगह लोकेट करके और उससे डाटा कलेक्शन करेंगे। वो भी बहुत बड़ी चीज हमारे यहाँ बन चुकी मतलब प्लानिंग में आ चुकी है। तो ये पूरी टीम वो भी काम करेगी। तो मैं फिर से बधाई देना चाहूंगा पूरी टीम को कि पूरी टीम ने बहुत अच्छी तरह काम किया है इस प्रोग्राम के लिए, और हमारे स्पीकर्स को भी मैं थैंक्स बोलना चाहूंगा। और मैं इसरो के भी लोगों जो हमसे जुड़े हुए हैं, जो हमारे साथ मदद कर रहे हैं, इनडायरेक्टली हमको बता रहे हैं कैसे क्या काम करना चाहिए, उनको भी मैं थैंक यू बोलना चाहूंगा। एंड आई विश बेस्ट ऑफ लक फॉर a great success of this seminar. Thank you very much.
Thank you, sir. Now may I call upon Chief Guest of today's function, Professor Mukesh Pandey, sir, Vice Chancellor, Bundelkhand University, Jhansi, to please say a few words.
Yes. First of all, thank you so much for inviting me on this inaugural function of this online FDP program of the 2 weeks on the design and development of academic institute nano satellite. On this virtual mode inaugural function, the dynamic, vibrant, energetic, enthusiastic director of the SGSITS Indore, and my dear friend, Professor Saxena Sahab, the founder of this CRSST, Professor S.K. Soni ji, Professor P.D. Bevare ji, head of the Department of Electronics, Dr. Anjana Jain madam, and the chief and the speaker of the today's inaugural function, Dr. P.K. Jain, and finally the persons who are coordinating all this 2 weeks FDP program, Dr. S.K. Jain, Satish Kumar Jain, and Professor Salen Sharma ji, the expert academicians from the ISRO and RRCAT, and all the 30 participants who are joining this today's inaugural function of this FDP program. It's a matter of great privilege and honor that SGSITS, under the dynamic leadership of the director and also assisted by Professor S.K. Jain from CRSST, has chosen the very particular topic on the nano satellite. Really, this is a need of the hour. If we will talk about the defense system of India, so certainly the nano satellite will play a very important role in weather forecasting and the environmental utilization, technology dissemination and the deployment. And also when we will talk about the emerging India and Vishwa Guru Bharat ki baat karte hain, teacher of the world. So certainly when the India will innovate and also apply this type of technology for the upliftment of the entire India, the Indian country certainly will be placed in the very top levels in the world. As far as concerned with the starting of the CRSST, really, as director has shared, how he has catched the idea, and after that he implemented this idea for as a center. Now the center is functioning in a very well way. Professor S.K. Soni has really done a wonderful work, and now I hope and I have been conveyed that Professor S.K. Jain is also doing a wonderful effort for the upliftment of the center. And day to day, he is involving new technology and by inviting the various experts from the state level and national level agencies. And this type of program will certainly create a current, create a vibrations for of the students and the youth and the teacher, how they can be motivated to do certain research and development work in the field of the nanosatellites. And really, if you will see, I have attended one meeting at the Delhi in the AICT also. When AICT is outlining certain emerging area or the hot topics, in which one of the, along with the drones and the robotic technology, nanosatellite designing, development and deployment is also a key area. If you will see, as per the startups, as per the unicorns, so certainly satellite field is also itself a very, you can say, the for the youth, there's a golden and diamond opportunity. हम जब बात करते हैं पूरे भारत की, कि भारत आने वाले समय में एक विश्व गुरु बनेगा, 8 ट्रिलियन इकोनॉमी होगी, हम बात करते हैं कि भारत आने वाले समय में जो अर्थव्यवस्था के क्षेत्र में 5th पोजीशन से 3rd पोजीशन पे होगा और पूरे वर्ल्ड को रूल करेगा, तो इसमें इस प्रकार का जो टेक्नोलॉजिकल एक्सप्लोजन होगा, तभी मायने में भारत एक सही दिशा में जा भी सकता है। और इसमें जो SGSITS में एक रिसर्च एंड कल्चर का जो इकोसिस्टम डेवलप हुआ है, इसमें मैं बधाई भी देना चाहूंगा डायरेक्टर साहब को कि उन्होंने ऑलवेज इस प्रकार के प्रोजेक्ट्स को, इस प्रकार की फैकल्टीज को बूस्ट किया है, और ये जो एटमॉस्फेयर है ये कंटिन्यू रहे, और इस प्रकार की जो FDPs रहते हैं, अटल FDPs रहते हैं, certainly they will accelerate and enhance the thinking, thoughts and activities of the institution. So on this occasion, I extend my best greetings and best wishes for the grand success of this 2 weeks program. And once again, I congratulate Director Rakesh Saxena ji and the coordinator of this wonderful program, Professor S.K. Jain Sahab and entire team. Thank you so much for inviting me in this program. Thank you so much.
Thank you, sir, for your kind and motivating words. It gives me immense pleasure to introduce to you all our speaker for today's session, Dr. P.K. Jain, sir. Dr. P.K. Jain, sir, has been working in Indian Space Promotion and Authorization Center in Space since its inception as founding director, program management and authorization, and is responsible for end-to-end management and processing of the proposals of the non-government entities to InSpace apart from issuing the required authorizations. He started his career with ISRO in 1989 and has worked for development and establishment of remote sensing and SATCOM Earth stations, implementation of SATCOM application programs like teleeducation, search and rescue, DTH-based disaster warning, dissemination system, etc. Before joining InSpace, he was leading a team of ISRO handling space spectrum management at national and international level, including ITUR activities as an associate director for frequency management and SATCOM planning at ISRO headquarters, and had actively contributed in carrying out coexistence studies between space and terrestrial services. He is a recipient of 2 ISRO Team Excellence Awards in 2009, IETE Biman Behari Sen Memorial Award in 2010, and D.V. Nirmal and Mangal Sen Award BES 2012. He has published more than 25 papers in various journals and magazines of national and international repute. Presently, he is also Vice Chairman of ITUR Study Group 4, Chairman of SWG 4C4 of WP4C of ITUR, and Chairman of National Study Group on Satellite Services. We are indeed very blessed to have Sir with us as our very first speaker. I request respected P.K. Jain Sir to please continue and take the session forward. Please, sir.
Thank you, Ms. Nair. Am I audible?
Yes, sir.
Yes, sir.
Yeah. Thanks, Ms. Nair, for introducing me. Now, can I share my presentation and then I will continue my speech?
Yes, sir.
Yes, sir.
Yeah, is my screen visible to you?
Yes, sir,
sir,
it's visible.
Yeah, thank you, Ms. Nair. And Honorable Chief Guest of this function, Director SGS ITS, Professor Jain, and the faculty of the SGS ITS, as well as dear participants. Now, let me begin with complimenting the SGS ITS, as well as the CRSST for choosing a very relevant topic for this faculty development program. And when I say it is relevant, I have the reasons to say so. As all of you must be aware, recently the government of India has opened up the space sector for the private institutes and the industry. And this is so-called space sector reforms, which was initiated by Honorable Prime Minister, and he himself had come to Ahmedabad to inaugurate our center in space headquarters. And since then, we are seeing a lot of activities in the country by the private entities, including the academia, in the space sector, and which we will see in subsequent to my presentation. I also heard the director of the institute mentioning about visiting ISRO for the nano satellite. It's very I'm very pleased to know that now the colleges or institute is planning now to work on the nano satellite. Probably some of the updates which I will give in my presentation, that the initially when the ISRO was supporting the academic institutes to deploy or develop their own satellites and then launch through their launch vehicle. Now the slightly changes are in the procedures since the formation of the in space, and now this activity of enabling the realization of the student satellites is taken up by InSpace, and InSpace enables the satellites realization, making access to the ISRO test facility and ISRO technical support, as well as launch of the satellite. So I will cover this in my presentation, that how your institute, or for the sake any of the academic institute, can proceed with realizing their own satellite, and what would be the SOP and the procedures. So let me begin with my presentation here. Now, these are the topics which I would like to cover very quickly. Of course, now we have already now 30 minutes, so I understand now there will be only 20 minutes for this session, Professor Jain.
Yes, sir. No problem, sir. You can carry it on.
So what I will do, assuming that some of you are already aware of the satellites and the satellite systems, but maybe few of, for the benefit of the few of the participants, I will cover very quickly an overview of the spectrum orbits, what are the satellites and different subsystems, assembly, integration and testing procedures. Then I will cover the...
Jain, sir.
Yes.
Sorry to interrupt you. Just a moment. We have 10 school teachers also.
Yes. So for that,
yeah. So you give your all basics also about nano satellite also. Okay. And freely you can speak in Hindi also if you want. No problem.
I don't have any problem.
Okay.
In fact,
Thank you.
yeah. Okay.
Thank you.
Thank you. So, so basically here, what I have tried to put in this my presentation, all the aspects which are required to realize a nano satellite or a student satellite by the academia. So this is what entire presentation contains that. So I hopefully that would be very useful to you. So starting with the spectrum orbit satellite subsystems, And then you need the ground segment and user segment. And of course, you should know what are the applications of the satellite which you are going to realize. So that all those things would be covered here. Then I will also take upon the small and cube satellites. What are their advantages? What are their different applications? What are the challenges in realizing those small or nano satellites? Then some of the aspects on the space situational awareness, which is important for you to know before taking up this project. The space debris and what all the regulatory guidelines in India as well as international. So that I would cover. I would also cover the third party damage liability for which the government of India is responsible. And then while we give authorization for any satellite, including the nano satellite, we also take care of or address this liability aspect. And accordingly, the regulatory guidelines are formulated by InSpace. So I will dwell upon that also. Then another important factor is the ITU process, the spectrum assignment. So how do you get the spectrum or the frequencies? How do you select the frequencies for the satellite? This is very, very important aspect. So this aspect also I would cover, which generally all these are, you will not find any in textbook. You will get only through the like interaction with the concerned expert. So I have tried to cover that. And then and the next session, I will now take up what is the InSpace roles and responsibilities in order to facilitate academia to realize their own nano satellites. And then the next process will be what is the process for the student satellites by the academic institution in India, right from step 1, from the design to the launch of the satellite and operation of the satellite. What are the things involved? What all the permissions you require? What all those things you have to do? So this is what would be my agenda. I will try to cover it slightly quickly, of course, because all these things will take a lot of time. But please feel free whenever you feel that I am going fast, and please feel free to intervene anytime as and when you require. Of course, we will have a separate session, question and answer session, the last session. So coming to the classification of frequency bands, most of the people must be knowing, but the frequency bands from 3 kilohertz to 300 gigahertz is the entire spectrum, which is used more or less for the satellite systems also. So right from very low frequency to the extremely high frequency, where the wavelength goes up to 1 mm. We call it mm wave band also. So this is what the entire spectrum, where you can see the different frequency band or the different frequencies are suitable for the different types of applications. And mostly the satellites today, what we are seeing is starts from the VHF, UHF, when some of the amateur satellites they operate, and then it goes to the further higher frequency bands. And these are the band which are popularly known as UHF, VHF, L, S, C, X. These are the bands which you will find very commonly in various literatures. And they're the different applications. Again, different frequency bands are meant for the different application. Again, the ITU, the International Telecommunication Union, it assigns the frequency bands for the different types of services. And every country is supposed to follow those assignments. Now, when it comes to the property of those frequency bands, now when you want to have the high bandwidth application, when you need the higher throughput, naturally the higher frequency bands up to Ka band, they become more useful. They can accommodate the more bandwidth and more data. So the lowest frequency band will have the lower throughput, higher frequency band will have the higher throughput. Similarly, when it comes to the antenna size, because of the wavelength, inversely proportional to the antenna size, you require the larger antenna for the smaller frequencies, and your antenna size becomes very, very small when you go towards the higher frequency bands. And the smaller antenna size is always beneficial for you in terms of transportation, cost, accommodation, and the handling and the tracking system and whatnot, including the beam width. Then when it comes to the spectrum, now again the bandwidth, when you say the narrower bandwidth you will get in the lower frequency band, larger bandwidth you will get in the higher frequency band. And you, for your user terminal, you have different outdoor units for the different frequency band. This is what generally commercially off-the-shelf systems are available. Then, but the drawback is the rain fade or the propagation losses. When you move towards the higher frequency band, the propagation losses increases. So based on those characteristics, based on the application, based on the ITU assignment of the frequency, you choose the appropriate frequency band for your satellite. Now, some of the basics of the orbit. What is orbit? So basically, when a satellite is launched, and you know that the Earth gravity holds it to a certain path, which is nothing but called the orbit, and it's the gravitational force of the Earth which is responsible to maintain the satellite in an orbit, and of course this is balanced by the centrifugal force. So this is why how the satellites stay moving in the orbit. And how do you the motions of the artificial satellites, the orbit of the satellite, what law they follow? So famous Kepler's law, which define the motion of the planets. 3 Kepler's law. The first one says the planets describe ellipses. When the sun is one of the focus, you can see in the diagram down. And the next law is the line joining the sun and the planet sweeps out equal areas in equal times. You can see again left side of the diagram. And the third one, very important, the squares of the periods of revolution of the planets are proportional to the cubes of their mean distance from the sun. And that means that as the distances or the altitude increases, the period of revolution also increases. So this is how it is. The same laws are generally artificial satellites also follow for the orbit. Of course, all these things you might have, you are the faculty also. You must be teaching all of the things. Something might be very, very primitive for you. There are different types of orbit: LEO, MEO, and GEO. This is low Earth orbit, medium Earth orbit, and the geostationary Earth orbit based on the altitude from the center of the Earth. And there are different types of categories of the orbits. Within this, there are special orbit, equatorial orbit, there are inclined orbit, there is a polar orbit. So I will take one by one what are all those different types of orbit. And again, different orbits have different applications. And again, you choose the orbit when you design your satellite. The orbit has to be selected based on what for the satellites are being developed. So the sun synchronous orbit, of course, your remote sensing center, you have your own institute. You must be certainly teaching this particular sun synchronous orbit, which is near Earth, near polar orbit. Basically, it is north to south, the satellite orbits, North Pole to South Pole. And this is gives the near constant ground illumination, which is very important for all remote sensing or Earth observation satellite. And why it is important? Because, and how do you get the sun synchronism is because orbital plane always maintains the same angle with respect to the sun. And that is how you get the constant ground illumination from the sun when your satellite is on that particular orbit. And because of this, the imaging by the satellite, it takes around the same time it covers when each day whenever it passes to a particular point on the Earth. It means that if you have a satellite, which is normally Earth observation satellite or remote sensing satellite on the sun synchronous orbit, then you can use this feature to monitor the progress of any the ground signature, say the crop monitoring or the forest monitoring over a period of time. When the satellite comes next time visits over the exactly same place, it sees the particular location on the Earth under the same sun illumination condition, so that you have all the conditions remain same. You capture the only change in the signature of the Earth of that particular region, and this is very important principle of the remote sensing. Then you have the other orbit, which is called the geostationary orbit. This is used basically for the communication satellites or communication, where you need the constant fixed antenna for the purpose of receiving the signals from the satellite. In the previous case, when you are using the sun synchronous orbit, your antenna has to continuously track or has to be continuously in the line of sight with the satellite, and this is the drawback of the basically the sun synchronous or earth station satellites, where the antenna has to constantly track, so earth station becomes a little bit complex and costlier. But whereas the geostationary orbit, the satellite is in circular orbit with inclination of 0 degree and eccentricity of 0 degree. It perfectly matches the Earth rotation period. It means this also rotates east to west, the way the Earth rotates around its own axis. And of course, but the again drawback here is you need more energy to place a satellite in the geo orbit, so the launch cost of the satellite is more or higher than the LEO satellite. There is a special satellite called a special orbit called the Molniya orbit, and this is very important, especially to cover the polar region, where normal communication satellite or the normal equatorial plane 0 degree geosynchronous satellite cannot cover the polar region. And when you have to have a connectivity to the polar region, especially like Russia, they have designed a particular special type of orbit where they put it very, very high inclination and very high perigee, very high apogee and very low perigee. When I say apogee and perigee, apogee is the farthest point from the Earth, for the orbit, and the perigee is the lowest point. So the advantage of that is that over the polar region or the intended coverage area, where the apogee is kept very high, and seeing the again Kepler law, third law, the velocity of the satellite becomes very, very less, and it becomes more or less stationary, so that the ground station antenna don't have to move very extensively, and the visibility to the polar region remains most of the time, say around 20 hours. And then when the satellite comes to the perigee, it goes very quickly because it is a perigee. Again, the movement or velocity of the satellite increases, and the perigee region where it is not intended to have the coverage, it goes very fast and then again comes to the apogee region. So this is what is called the Molniya orbit, which is even now also is being used by the Russian communication satellites. This is some of the important geometry, and which is important for us to know that there are different types of push and pull forces, which is from the solar, from the sun, as well as from the Earth. Its own Earth is not a perfect sphere, perfect sphere. So that also puts some particular push and pull to the satellite orbit, and because of that, the satellite will not remain perfectly in the orbit, and based on the season, whether it is a summer solstice or the autumn equinox, the pressures or the push-pull changes, and that they need the maneuvering of the satellite in order to keep them into the intended orbit. There is another important thing, the eclipse, because the satellites also suffer from the eclipse, and as you can see in the diagram, and in such case, when the satellite passes through the eclipse region, it doesn't have the solar power for its solar panels, and that time all the operations of the satellite have to be moved to the battery. And then accordingly, you have to, when you are designing your satellite, you should also have the battery systems to support during the eclipse period. Now, this is what is the sub-satellite point control box, we call it, in the lower side when you see. Because of those push-pull and because of the orbit perturbations, the satellite orbit does not remain same or constant or with respect to a stabilized, with respect to all these three axes. We call it roll, yaw, and pitch. There are three axes where over which the around which the satellite is maintained in the orbit. And for that reason, now we need to do a lot of maneuvering, periodical maneuvering of the satellite using, we put some thrusters in the satellite for this particular reasons, and the satellite has to be maneuvered using those thrusters, and to keep them within the plus minus 0.1 degree. So suppose you have a communication satellite which is launched at 74 degree east equatorial location, then it has to be maintained within plus minus 0.1 degree of that 74 degree. So and that has to be maintained through the maneuvering. We call it also station keeping. It is east-west station keeping as well as the north-south station keeping, depending upon the what type of forces it is going through. So having gone through the spectrum orbit, now let us come to the satellite and its satellite subsystems. Now, what is satellite actually? It's nothing but a bus system, a platform which houses the communication payload. Communication payload is the heart of the satellite, which does the function, or which provides the function for which the entire satellite is being realized, the intended application, and that is done by the or provided by the payload. And the spacecraft bus system consists of the various subsystems, which we will see in the subsequent slides. There could be different types of small satellites, medium and large satellites. Small satellites will have different category. We call it pico, nano, micro, mini. So whereas the medium and large satellite will have typically 1000 kg to typically 6500 kg. We are having some satellites now coming up with 6.8, 6.9 kg also. Now, what are the different subsystems of a spacecraft? So, attitude and orbit control system, as I mentioned earlier, previous slides, that the satellites have to be maneuvered, the station keeping operations have to be performed periodically in order to maintain the satellite attitude along its all three axes. And for that, these spatial systems are required for maintaining this orientation of the spacecraft, because if the orientation changes, the satellite antenna orientation will change, satellite solar panel orientation will change, so that entire the system of the satellite get disturbed. It's very important, the subsystem of the satellite, and it is done through the various sensors, processors and actuators. There is earth sensor, we use star sensors, different types of sensor which are used to maintain or derive the information to maintain the orbit and to provide the correction through the maneuver. Then we have the electrical power system, which is responsible for generating the required power through its solar panel to the various parts of the spacecraft or satellite. It contains the solar panels to generate the solar power. In case of eclipse, the batteries are there and the various power electronics. Similarly, the thermal system, which is responsible for maintaining the temperature of all the subsystems of the satellite within its own specification. As you know, the space environment is very harsh. The temperature varies very, very widely, say from plus 185 degree to minus 125 degree centigrade or so. And it is important that the temperature of where is the electronics generally operates in 0 to 50 degrees centigrade typically, and the space environment. So the thermal system is responsible to maintain that particular temperature for the electronics of the satellite subsystem, and it is done through the heaters, through thermistors, various heat pipes, insulators, and so on. The other important system is propulsion system, which is required to maintain the satellite in the orbit. As I was mentioning, there are various thrusters which have to be switched on, and they operate through propulsion. There is a satellite is in its own propulsion system because generally the one method of launching the satellite or keeping it into the geostationary orbit is to use the GTO. We call it Geo Transfer Orbit. While launching the satellite, when we launch, we don't launch directly to the 36,000 by 36,000 kilometer. We launch it to a geotransfer orbit, which has the apogee of around 36 to 40,000 kilometer and the perigee of around 250 kilometer. So it's an elliptical orbit, and this is to keep the cost of the launch low. And afterwards, we use the thrusters in the satellite to raise the orbit, raise the perigee from 250 kilometer to 36,000 kilometer. And that is how afterwards we achieve the 0-degree inclination and the geostationary orbit over a period of time through the different maneuvering operation. So for all these needs the propulsion. So the propulsion system has the different tanks where it will have the separate oxidizer tank, separate fuel tank, and the different plumb lines, thrusters, and the pressure regulator. So this is one electronic system, the propulsion system, which is again important for the satellite. Then we have the basic structure and mechanism. The structure which provides the support to all the subsystems of the spacecraft, which should be very stiff, but at the same time, very light composite material, because each and every kg of the satellite, you are increasing the cost of the launch and as well as the maintenance of the satellite. And of course, the satellite will have different deploying systems like solar panels. It will have the antenna which could be deployed afterwards. So all those mechanism for deployment also would be contained in this structure and mechanism subsystem. Then we have the telemetry tracking and command. To know the health of the satellite continuously, it has to be monitored through telemetry. Then we need to continuously track the satellite in order to know its orbit and be able to command it. So the command goes from the ground to switch on off the payload or the management of the satellite. So this is a telemetry tracking and command system which uses various types of modulator, demodulator, receiver, actuator, transmitter, and so on. And then the payload, which is the heart of the satellite. There could be different types of payload depending on what is the objective of your satellite. It could be communication payload, it could be earth observation payload, some camera or the radar, the microwave radar. It could be meteorological payload, it could be navigation payload, it could be scientific payload like we have seen Chandrayaan or the Mars mission. So the payload is the important heart of the satellite. And if it is a communication payload, we know it receives the ground signal, translates to a different frequency, amplifies and send them back to Earth. Earth observation will have different. So on camera, it provides the Earth imagery and the data. And so the payload will have the different types of electronics, including antenna, multiplexer, demultiplexer, amplifier, and so on. This is the exploded view of the satellite. You can see here if I maybe you can see my cursor. This is the TTC antenna. Then this is telemetry tracking command. Separate antennas are there. These are the TTC antenna. Then you can see the TTC horn. You have the different sensors, earth sensor. This is the west panel. Actually, we have the different panels where all the electronics and different subsystem which I described would be mounted on that. You can see here the reflector, the KU band antenna. This is a KU band satellite. So this is also another antenna which will be on both sides. It will be, this is a deployed condition. Solar panel you can see. The thrusters you can see here. These are the small thrusters which are used for the station keeping. And this liquid apogee motor is also used for the raising the orbit from GTO to the geostationary orbit. And these are the pressure and tank. You can see the oxidizer propulsion tank for oxidizer and as well as the fuel. And this we call it north panel. This we call it south panel. North panel and south panel contains generally all the payloads, and the east and west panel contains the other electronics along with the reflector or antenna. This is general configuration of any satellite. You can see the disassembled view of the spacecraft here, a more or less similar type of systems where you can see probably more prominently. This is the deployed view once in the deployed condition after the launch when we deploy the solar panel as well as the antenna, both the antennas. Now, the next activity after realization of the satellite is the spacecraft assembly, integration, and testing. Some of the facilities which are required to do those type of AIT activities, which ISRO has. This is all the photograph of the ISRO facilities, where you can see the electronic subsystem fabrication, the hills testing, the structure, the propulsion integration, disassemble mode, IST is happening. The spacecraft, once we close the panels, all the panels, how does it look like? We do the thermovac testing in the thermovac chamber, the balancing of the satellite, so counterweights or something, if it is required to be put, we put there. The solar panel deployment testing, vibration test, acoustic test, CATF for the antenna, the RF test, the antenna characterization and antenna patterns. These are the different things. Now, these are the steps which is required for the spacecraft assembly integration activity. First, the structure comes to the clean room, where you will have the entire structure. Then the propulsion system is separately assembled. And then afterwards, once all the subsystems are available, we do the open mode integrated system testing, where all the systems, though they are open, but they are all connected, and the satellite is tested for that. Then we do the integration of the panel. It means all the north, south, and east, west panel. We will close and then do the close mode integration system testing, again for the entire satellite. Then the satellite goes for the acoustics testing for the various, because during the launch, there is a satellite undergoes through a very heavy acoustic vibration. So the vibration testing is done. And then afterwards, all the physical parameters like its mass, weight, the length, size, those things are measurements are done, the center of gravity and all. Then solar panel deployment testing is done. Afterwards, we do the thermovac testing, where the satellite is subjected to the extreme temperature which all its subsystems are supposed to undergo, the cold as well as hot test. Then afterwards, final test is the entire satellite taken to the CATF range, and then that is compact antenna test facility, where the satellite final testing is done. And afterwards, we containerize it. Satellite is put into the container before transporting it to the launch site. So this is what is the assembly, integration, and testing which is done at for any satellite. Now come to the ground and user segment. Now for any satellite, it is not only the satellite project you have to make only satellite. Of course, you should have and you should plan the ground and user segment also. Now there could be a different types of ground segment and user segment required for the different types of application, or what is the objective, what type of satellites you have. It could be if you have the remote sensing satellite or Earth observation satellite, you need Earth observation data receive station. If it is a satcom or satellite communication satellite, it uses a satellite Earth station. If anyway you are supposed to do the telemetry tracking and command, for that a separate Earth station is required. Or if you have to hire those services, otherwise you have to put your own TTC Earth station. You have to have your own spacecraft control center, where the satellite could be controlled and all its payload and other thing can be managed. In order to have that to the end user, the user terminals are required in order to take the signals from the satellite to the end users. If it is an amateur satellite, you need a separate amateur satellite Earth stations. And if it is Earth observation satellites, apart from the data receive Earth station, you should also have the facility to process the data and make the products, the APIs, and the other types of applications. Now, if you see the right side, the typical configuration of the ground station, where you can see the right side, the satellite is you receive the signal from the satellite transmit antenna to your ground station, which will have the receive feed or receive station, receive antenna, which goes to the low noise block converter, or sometimes it will have the LNA, depending on how big the station, Earth station is, to control the G/T of these basically Earth station. Afterwards, you put to the demodulator, because the signals coming from the satellites are the modulated one. After demodulation and decoding, you finally get the information output. I'm giving very, very simplified. It's not so simple, of course, the Earth station, but in general, what are the basic building block. And now when you have to transmit the signals to the satellite, because satellite communication satellite especially is simply a repeater. I'm not talking about the Earth observation. If it is Earth observation satellite, you have only the receive chain. It's a receive station. But if you have the communication satellite, then you have the transmit ground station also, where that you encode the signal, modulate it, put it to the up converter to the particular frequency which is received by the satellite, and amplify it through high power amplifier and transmit through the antenna to the satellite. So this is what is the general ground and user segment. Now, what are the different types of application? A plethora of applications. If you take only the communication satellite, it's n number of right from the traditional heritage television, telephone services to the now the upcoming emerging services of SATCOM on the move, or the mobile satellite services, or the in-flight and maritime connectivity, some of the societal application like teleeducation, telemedicine, and so on. The VSATs, the services is one of the very important services which right now satellite is supporting, which will provide even the broadband connectivity. Sometimes the direct to home. Nowadays we are getting from the higher frequency band like Ka band or Ku band. The delivery could be the B2B, business to business, or it could be directly business to the customer. So we have varieties of application. Of course, the navigation services have its own applications. You might have heard of a lot of GPS, GLONASS, and then our own Indian IRNSS system, which will have its own navigation PNT services, that is position, navigation, and time. Now, when it comes to Earth observation, again, there are a variety of application. This all of you certainly must be aware, because you are running your own remote sensing center, where right from the agriculture, soil to forest, water, land, disaster, coastal, ocean, it's a number of application of the remote sensing or Earth observation, which we have been using. India has been using, across the world people are using from the Earth observation satellites. Now coming to the small and cube satellite. So as I mentioned, the large satellites more than 1000 kg general is a general classification, not very hard and fast. Generally, the small satellites between 500 to 1000 kg. There are CubeSat, different CubeSat, right from mini to femto, of the different based on their mass. And again, some classification: 1U, 2U, 6U, 12U, and 1U means 10 by 10 by 10 centimeter. This is what is general terminology which we use. Some of the ISRO satellites of small satellite category, you can see which ISRO has made. And now you see the latest trend, which is picking up now. If you see from 2016, 2018 onwards, where the total number of satellites which are realized across the world, the percentage or proportion of the smaller satellite is much higher. And this is what is picking up now. And that's what I told, that this is quite relevant now, that your institute also has embarked upon taking up this particular satellite realization, nano-satellite realization. Now, some of the features, salient features of the CubeSat or a small sat. The first most important thing, you have the reduced cost of realization, and because you can use now the 3D printing, it's very common nowadays. Including the additive manufacturing, and the commercially off-the-shelf components are available. In fact, you don't have to be very harsh on the space qualification component, because you can afford to lose some of the satellites even if they fail, because the cost is very less, including the launch cost. The turnaround time for realization of the satellite, generally for communication satellite, we take 3 years time, and 3 years time is very optimistic. Whereas the CubeSat can be produced in 15 days to 20 days, 3 weeks time, people are producing now, as quick as possible. The testing, as I was telling, the testing standards, you really don't have to subject the satellite to a very harsh test, because again, you can afford to lose some of the satellites. The spectrum utilization is another important thing. You can put the same spectrum for the geostationary satellite, and the same exactly frequency, same spectrum for the same location, you can use the small satellite also. So this is again efficient utilization of the spectrum, which is a very, very rare resource. And of course, the amateur satellite is part of that. A lot of amateur satellites are coming, and I hope that you people are also trying to make the amateur satellite, because that is much easier to coordinate in terms of the ITU frequencies and all. But all these features or advantage doesn't come without the challenge. The most important or the aspect is the debris mitigation. Because of the number of satellites, the sheer number, they add to the debris, and the debris mitigation guidelines, which are very, very strict, stringent, it is very difficult to follow in the realization of the smaller satellite. Otherwise, the satellite becomes costlier. So that is the reason that space traffic management becomes very complicated, because you have a lot of not only creating the clash environment to the existing other satellite, but as well as you are also supposed to safeguard yourself from the clash of with the other debris or other satellite. The frequent replacement is required because lifespan would be very short, typically 5 to 6 years, and the quality assurance, again, because you don't subject it to the very harsh testing or relaxed testing standard, you have to maintain a very good quality. So that is some of the challenges. In India, we have a lot of opportunities. We are seeing in space has been receiving plenty of applications from the satellite manufacturers of the small satellite, including the academia. We have been receiving the application from various colleges for the realization of satellites. Right now, we are going ahead with some of the MIT, we are going ahead with IIT Chennai, we are going ahead with IIT Bombay. Some of the satellites which we are making now are permitting them. Even for the downstream application and user segment, we have a lot of opportunities in India. Some of the applications, the typical common application which people are using now, which we are seeing in space while we are receiving the application, people use for technology demonstration, carrying out various experiments, especially the colleges. They use this for the small experiments. Some of the startups, they use it to build the heritage, to showcase their capabilities to their customers, and also the test bed. We are seeing the constellation of communication satellites coming. You might have heard of SpaceX, OneWeb, Starlink, the Telesat. They are all being used for providing the broadband with very, very low latency, because it's in the LEO orbit. Internet of the things, as well as the communication applications, the thin route applications are being provided by these small satellite. This is again emerging application. The Earth observation is a very common application which we have been seeing. Disaster management, on demand the data supply, because these are very, very agile satellite. You can always provide the data on demand. Some of the strategic applications people are using, the defense people are using this, and the vessel tracking or the land tracking, or even some of the aircraft and other tracking also, people are using this smaller satellite. Amateur radio is a well-known application. Some of the challenges in the realization of small satellites. Now, if you see from the right-hand side wise, first of all, when you take upon this satellite, you should know the objective of the satellite. Afterwards, once you know the objective, you have to choose accordingly the orbit and whether you need a constellation of satellite or only one satellite would be suffice for you. Then you have to design the space segment or realize the space segment, which will mainly payload and the spacecraft bus, which type of bus you need, the 1K bus, 2K or 3K bus, and then the launch, what type of launch you should have. The ground segment and user segment is another thing which you need to plan. And throughout the operational life, how do you do operations of the satellite, including the command control and the spacecraft control and the communication. So these are the things which you have to do the planning before you take up the realization of the small satellites. Now, how do you do that? See, if it comes to the three important things: space segment, user segment, ground segment. For a space segment, again, this is very, very important, because if you have to do the rapid development using the innovative technologies like 3D printing and all, you have to accordingly choose the spacecraft design and basically again accordingly orbit and payload. When it comes to the ground segment, what type of satellite operation you will do, whether you will receive from one ground station or across the earth, or maybe within India, how many earth stations you will have, so that you will have the maximum data, because the visibility of the satellite would be only for the limited period of time, 10 to 15 minutes only the one satellite pass would be there. And then how whether you are going to share or you want to have your own ground station. And similarly for the user segment, what type of processing and data dissemination management you will have, or what are the scheme you will have. And of course you need to have a lot of technical support for the data dissemination, including your customer base. Some of the industry in India which are now in the business of realizing the satellite, manufacturing the satellite, which we have been receiving the application. Dhruva Space is there, Agista BST, Anand Technologies, ITCA is making all the satellites for the academic institute. They are currently going ahead with the 75 satellite project, where they have taken approval from us, rather than we have been supporting them now. And the other one is the ADTL. And then some of the people who are using this small satellite for the Earth observation constellation, they are having their own satellite, their own Earth observation data, and they are having their own data product. They are Pixel, Adya Space, Satsure, Digantra. Digantra is in the field of space situational awareness. The Space Kids, you might have heard of, Chennai. They have recently launched the Ajadi Sat 2 satellite, which is again done by the students. It's academia, but it is a startup taking help of the students for making the different types of satellites. So now we are 8:15. Do you want to take break, or I can continue for another 10-15 minutes?
Continue, sir, please. Continue.
Okay. So the another important topic is space situational awareness. Now, as I was mentioning, this is very important topic you will not find in the textbook. Now, information, this is not what, this is actually to have the proper information about the space environment and its effects. And because when you are making this, you are launching your satellite, operating satellite, you should know that what type of a space environment it is going to have. And this is basically related to a space debris, where you are supposed to detect the space debris, identify it, track it continuously, and monitor also that its movement, so that you will safeguard the operational satellites. Now, why it is important? Again, because the space is a very important subject which is being used for both civilian as well as the military purposes. Now, you should have the certain necessary action is required based on the identifying the space debris. You can avoid the potential collision with the space debris, and especially when you do the re-entry of the human space missions or the space shuttle and all, it's very important to monitor the space debris, so that this matter of life of the astronauts. So the long-term sustainability of outer space, you have to keep using the outer space for the long-term manner. So you should keep away from the space debris, and to manage the vulnerability and mitigate the threat. How do you mitigate? I will see in the subsequent slides. If you see the space debris, now you see the situation. In 1957, this was the extreme left side. You can see how the space looked like, and now you see the 2018 and the one of the prediction 2030, where you will see all clutter of the space objects only. Right now you see that more than 7,000 satellites, out of which 3,000 are only active, 250 million debris of less than 1 centimeter estimated, and less than 10 centimeter 1 million, and 25,000 greater than 10 centimeter. And remember that greater than 10 centimeter only today can be tracked. Below that you cannot even track. They are all unknown object to you, and you can imagine the gravity situation. And the space debris could be in terms of the rocket stages. When we launch, the spent rocket stages lying there only, they keep orbiting. There are stray bolts, nuts, paint chips, so all type of the scattered fragment. Somehow we are seeing the anti-satellite test, and which has created a lot of debris, the fragments of the satellites. And the one very example of an European space satellite, NVSat, which is size of double-decker bus. It's lying there, and everyone wants to somehow remove and that is a challenge for people. This of course you can continuously track, but it's a very dangerous object, space object, which keep doing. Now you see imagine the implication of space debris size. See the left side end of table. Just 1 mm debris size, 1 mm, it will have the energy similar to a baseball. And moment if it becomes 3 mm, it is as good as the energy of a bullet. And imagine the bullet is hitting your satellite. It can cause the damage permanently, failure. 1 centimeter is a flying anvil, and 5 centimeter as good as hit by bus. And just 10 centimeter, which is currently trackable, it's like a large bomb has been splashed upon your satellite. And you see the right side. Today, what you can track, it's only 10 plus centimeter which you can track or catalog. But all 1 mm to the 10 centimeter has a different types of threat to your satellite. Some cannot be tracked, some cannot be mitigated, some sheer by luck. This is what is the scenario. So the LEO, especially because you currently are going for the LEO satellite, smaller satellites. Why that LEO orbit have been congested? Because of the emerging technologies of the mega constellation for the communication, for the broadband, by the constellation of satellite which are having the thousands of satellites. You see the Starlink by the SpaceX has the 12,000 satellites it is planning. OneWeb, it is planning something around 1,000 satellites. So these are the satellites, number of constellations are coming up, which are adding more and more satellites and more space debris to the LEO orbit, making our things much more difficult. And what are the repercussions? One very, it is called Kessler syndrome. The debris hits a debris, creates more debris, and this is a runaway cycle where the debris collisions and creating the finally making maybe a prediction in future that totally the LEO orbit unusable. There is another threat is the light pollution. Today, what all the astronomers or astronomy is happening for all the planets, interplanetary missions and all, they have the threat now because all this space debris is increasing the brightness of the night sky. And this is a very alarming situation where United Nations has been discussing this for last 15 years. There is a separate working group in the United Nations. Of course, I have attended that particular group also, where they discuss only the mitigation, debris mitigation guidelines, and what are the potential steps they can take. In short, the space situational awareness contains the tracking of the object in space, basically more than 10 centimeter. Almost more than 90 countries and private entities are doing this job already in this particular, involved in this activity. It includes the monitoring of the space climate, space weather, solar storms, and characterization of the space objects, and the predicting finally threats to avoid the collisions and other things from for your space object. How do you do that? There are different sensors which are employed. There could be space-based sensor, there could be ground-based sensors. Like we have the multi-object tracking radars, we have the space-based ranging transponders, optical telescope, LIDAR, laser-based radars, as well as some of the navigation-based system which are being used. We also, our own ISRO also has our own Netra project. I will have in the next slide, and some of our own radars. How do you do this positioning, object position, and the prediction of this thing? There are several algorithms are being generated. We have the two-line elements, which is generally nothing but the ephemeris and state vector of the satellite, as well as of the space object or debris, which is provided by the NORAD. NORAD is again a North American defense agency, a consortium in Canada and US together. They have the good facility where they identify, catalog and track the space debris. They provide all the space objects, including all the operational satellites, the TLE and the space vector, which is freely available to all the people. Maybe when you put your own satellite, if you don't give or take the support of ISRO, probably you may have to take the support of some of the other service providers to prevent your satellite from the space debris. What do those simulation software do? They do the conjunction analysis. Conjunction analysis means that what is the probability of the collision of the space debris with your satellite, and there are different approaches. Some could be the minimum distance approach. Some minimum distance you will find and the alert will come to you, but that is not very accurate method. Unnecessarily false alert also comes. And the other method is using the maximum probability. How much probability is there or probable that the debris will hit your object. There are different algorithms. It's a very big, vast subject, but I thought that some glimpse, some idea we should have here on the type of things which are involved in the space situational awareness. So based on the threat alert which you receive, generally it is received from US Space Command body, which does the tracking of the object. They give the alert to the, you may have to register with them. When you launch your satellite, they give you the alert for the collision alert. That time, if you have the manual facility in your satellite, you do the collision avoidance maneuver by putting the thrusters on. If you don't have the maneuvering facility, which generally you will not have in the smaller satellites for the sake of saving the cost, that time you will inform the other satellite fellow that, look, you are going to hit me, please maneuver, please move away from my satellite. Something like that, some mitigation technique and all you might have to adopt. There are, as I was mentioning, several guidelines the UN has been discussing, international community has been discussing on this. There is one committee, IADC, which this is the interagency committee for the debris mitigation, and where it provides the guidelines. Guidelines could be that how the debris has to be controlled when you launch the satellite, the upper stages and appendages, how you have to passivate, how do you prevent the on-orbit collision, how do you minimize the on-orbit breakups. All those guidelines are provided by IADC. Similarly, by the ISO, there are UN guidelines also. One important rule which generally is guidelines are provided by that once you put a satellite and the satellite expires, satellite life is over, it becomes a debris, you should take the necessary measures such that in 25 years at least, the satellite should be pulled down and should enter into the atmosphere and gets burned down so that it doesn't remain as a debris. So for that, special measures are to be taken. Satellite has to be pulled down before it is going to be expired, and that is called 25-year lifetime. That is what general guideline. However, the US is insisting to adopt 5-year rule for the smaller satellite, for the LEO satellite, to dispose, so that in 5 years time, after the expiry of the satellite, within 5 years, your satellite should be coming to or re-enter into the atmosphere and get burned down. It's not only the satellite, even the launch vehicle, the spent stages also should have that similar treatment. So as far as India is concerned, now as I was telling, ISRO has recently launched one project Netra, which is nothing but the network for the tracking and tracking the space object. And this has the collection of the hardware and software, including those connected radars and some of the software and simulation software for the space traffic management as well as space situational awareness. And we also have the multi-object tracking radar at Sriharikota, SDSC Shar. We have the DRDO also has put up now recently the Super Swordfish radar, which they are also doing the space situation awareness tracking. Now, some of the non-government entities, private industry also are coming forward now we have again received the proposal. InSpace has received the proposal from Digantra, who are now going to put one telescope at Dehradun. They are putting their own satellites also for monitoring the space environment and radiation characteristics, so that they want to use this to map the entire space for the debris mitigation. YETS is another company which is coming up. They are developing their own software. And some of the global service providers are there who provide you the services of the debris alert, like Leo Labs and all. So when you put up your satellite, probably either you have the option to go to the Leo Labs type of service provider if you want to safeguard your satellite, or you tie up with ISRO. ISRO provides the services on commercial basis. There is one more important thing here, is a third-party damage liability of the state, because there are certain treaties, international treaty and convention, which deals with the third-party damage liability caused by the space object, and where especially the two convention, Liability Convention 1972 and Outer Space Treaty 1967, both of these convention and treaty put the launching state absolutely liable for any third-party damage happens to the of the other country, and it is an unlimited liability. It could go into the millions, billions of dollars depending on the type of damage. And the government of India, suppose, because India is the signatory to these treaties, if anything happens from the space object by Indian space object, it could be from the academia, it could be from the private player, it could be from the government, it could be from the ISRO. Anything, any damage from our space object happens to the space object, or any damage to the other party, third party of the other country, government of India is liable to pay the damage. And because of this reason, now we have to have our own regulation when we authorize the any space activity, any launch or any satellite by either government entity or by the private entity or by the academia. Now we have set up the regulatory guidelines. InSpace is the body who is authorizing, who is formulating those guidelines, who is ensuring that those guidelines are followed, and we issue the authorization. In fact, I am the director of the particular area where I issue the authorization for any of the launch or any of the satellites taking place in ISRO, in India, including ISRO. So some of the third-party liability, if you see global scenario, this is not only the India now which we have put down guidelines, we have put recently, but in across the globe, this is the worldwide practice. So far, because in India, the private entities were not participating in the space activity, so we had not put those guidelines. Now, because the space sector is open for private entities in India, now we have put those guidelines. But in the other countries, like USA, UK, the private players are the major player apart from government. They are having these guidelines where the insurance, a third-party damage insurance is important, required to be taken to address the state liability by any entity who's taking up the satellite launch or the simple launch operation. And generally the satellite operators are exempted for taking the insurance in some of the countries. And there is a maximum limit of the insurance, upper limit, like US has the $500 million. And I will tell you what India we have given the guideline. More or less, Australia, France and Japan are relatively lesser than the USA. And this is what is the maximum limit of insurance. Beyond that, if any damage happens, beyond that, if any claim happens, that becomes the government responsibility again. But up to this point, at least the insurance should cover the damage. This is what is the guideline. Now, this is what in India. So now, as I was mentioning, that we have formulated now our own guidelines in India recently. It is under approval right now. We will expect that in a month's time, the regulatory guidelines would be available in our website. So we are also telling now third-party insurance to be maintained by the non-government entity. There has to be mandatory adherence to the UN space debris mitigation guidelines when you design or realize your satellite or launch vehicle. Generally, the satellite operators will be exempted from the requirement of maintaining the financial guarantee. This is to encourage the satellites realization by the private sector, including the academia. We don't want to burden them with the insurance premium and all. So that is the reason we are exempting them for taking the insurance. But the launch vehicle operators has to take the insurance, and the insurance amount would be depending upon the maximum probable loss methodology, where we will calculate, in a space will calculate the possible failure, possible accident scenario, and the possible damages which could happen. We will decide what should be the premium, what should be the insurance assured sum, the insurance value. But of course, that will be subject to the maximum cap. Right now, I am not giving the figure because it is under approval, but it will be to the tune of 500 crore, where the maximum insurance would be, we will be asking the non-government entity to obtain, and with an insurance period of 1 year. Of course, the insurance period would vary depending upon the type of the launch. So this is what is the guideline which now under consideration and which will be in place. Now, so how do you cover the so much of risk which you have talked about? You have the risk while launching also. There could be launch failure. There could be a satellite failure. There could be a debris hitting the satellite. So generally, what type, how do you risk management you do to protect your satellite at least? They do through insurance. It's a worldwide practice. We take the insurance either satellite as well as for the launch vehicle. The sum of the insurance right from the beginning, right from the transportation of the satellite from your college or from your factory to the launch site, and then ignition of the launch to the in orbit, entire period seamlessly, the insurances are available. Some of the insurance are available only for the launch services. Some of the insurances are available only for the after the satellite is put into the orbit, then the in orbit insurance it is called. Excuse me, yeah.
I'm unable to listen to you.
Hello, sorry sir, I am in a meeting. I will call you later. Yeah. Sorry, I thought Professor Jain has called me because there was some S Jain. I'm sorry. Okay. So, so this is what generally is the different types of insurance which are available. And the last topic for this session, if you allow me, otherwise I can take in the next session.
I think next session will be better. When you will take next session?
Fine. So the next session I want to take ITU and then the procedure for the in space and your nano satellite. Maybe after 5-10 minutes break.
I just want to know how much time you will require more to speak.
I can keep on talking. So it's up to you how much level you have got the patience and the energy to listen to me.
I'm Professor Soni.
Yeah.
I'm in dialogue with you. There are some other participants from institute schools also and all these things. So I think Professor S.K. Jain has called you because, I think he can clarify because it's already 8:30. How much? I know you are a good speaker also. Can you go tomorrow?
It's okay. No, I will not like to take up tomorrow. Maybe I can quickly finish. If you see, if I have to finish by 9 I will finish. If you say 9:15, I will finish 9:15. It's up to us.
So the official time is till 9:30. Soni said that, yeah, it is till 9:30.
Take another lecture. We'll finish by 9:30. That
after 10 minutes break, maybe we can start again.
After 10 minutes
if
break,
everyone is comfortable.
With another lecture.
Fine. Okay then. Okay. Let's assemble after 10 minutes.
Okay, sir.
Hello.
Jain sir.